science, we go deep. Dreams to chase, goals to keep. Every question's like a code to crack. Think it through, don't turn back. We don't quit, we learn with power. This is our time, sharken hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. Welcome to Sharken Hour. Ay, ay, ay. In the lab or in the class, we make ideas that last. Logic sharp and so are we. Learning strong, setting knowledge free. From algebra to chemistry flame. Every topic we play the game. Confidence grows minute by minute. Sharken Hour, yeah, we're in it. No stress, just progress. We push limits, nothing less. Every challenge, every test, we rise higher than the rest. Sharken Hour, now take the stage. Learning's cool, it's the new age. Solve, create, don't ever cower. Keep on shining, Sharken Hour. Sharken Hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. SHARK, yeah, we are. Yeah, we got that brainy power. We grow, we glow. Oh yeah. Yeah, we're back in the zone. Grab your pen, switch your phone. Knowledge calling, can't ignore. It's Sharking Hour, let's explore. It's not just math, it's mind in motion. Ideas flow like waves in the ocean. From numbers to science, we go deep. Dreams to chase, goals to keep. Every question's like a code to crack. Think it through, don't turn back. We don't quit, we learn with power. This is our time, Sharken Hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. Welcome to Sharken Hour. Ay, ay, ay. In the lab or in the class, we make ideas that last. Logic sharp and so are we. Learning strong, setting knowledge free. From algebra to chemistry flame. Every topic we play the game. Confidence grows minute by minute. Sharken Hour, yeah, we're in it. No stress, just progress. We push limits, nothing less. Every challenge, every test, we rise higher than the rest. Sharken Hour, now take the stage. Learning's cool, it's the new age. Solve, create, don't ever cower. Keep on shining, Sharken Hour. Sharken Hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. SHARK, yeah, we are. Yeah, we got that brainy power. We grow, we glow. Oh yeah. Yeah, we're back in the zone. Grab your pen, switch your phone. Knowledge calling, can't ignore. It's Sharking Hour, let's explore. It's not just math, it's mind in motion. Ideas flow like waves in the ocean. From numbers to science, we go deep. Dreams to chase, goals to keep. Every question's like a code to crack. Think it through, don't turn back. We don't quit, we learn with power. This is our time, Sharken Hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. Welcome to Sharken Hour. Ay, ay, ay. In the lab or in the class, we make ideas that last. Logic sharp and so are we. Learning strong, setting knowledge free. From algebra to chemistry flame, every topic we play the game. Confidence grows minute by minute. Sharpen our, yeah, we're in it. No stress, just progress. We push limits, nothing less. Every challenge, every test, we rise higher than the rest. Sharpen our, now take the stage. Learning's cool, it's the new age. Solve, create, don't ever cower. Keep on shining, sharpen our, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. SHARK, yeah, we are. Yeah, we got that brainy power. We grow, we.
All right. Greetings, guys. How are we? I hope we are all doing very well. So, welcome to Shakin Hour. This is the time where, as students, we come together, we learn, and we look at some past objective questions. Are we okay? So, over here, I write the questions for us to give or attempt the questions and then say our answers in the live chat. As always, I'll write down the questions, write the possible options. If you know the answer, you just let me know the answer. Are we okay? So, guys, that is what we'll be doing tonight as usual. So, tonight I have questions on what we call mensuration 2. So, basically, we'll be dealing with area and volume calculation of pyramids, cone, circles, all those things. They are under measuration 2. So that is what we'll be doing. All right, so today I have a very interesting set of questions for us. So the first question we are going to solve, or the first problem we are going to tackle, is like this. So we have, okay, this obviously not drawn to scale, but this is an angle. The length over here is 14 centimeters. The angle over here is 270. Okay, so we have here the diagram. The diagram shows a sector of a circle of radius 14 centimeters. Okay, so the angle at the center is 270 degrees. Are we okay? The sector is folded. The sector is folded to form a cone. Okay, so now using this preamble, we have to answer question number 1. Find the radius of the cone. Find the radius of the cone. Okay, so this is the first question we have based on the preamble that we've given. So we have here option A is 73.5 centimeters. Option B, we have 28 centimeters. Option C, we have 14 centimeters. And then option D, we have 10.5 centimeters. All right, so guys, this is the question that we have. We have the diagram over here, and this is the description. So the diagram shows a sector of a circle of radius 14 centimeters. The angle at the center is 270 degrees. So the sector is then folded to form a cone. Now, based on this preamble, we have to find the radius of the cone. So we have option A, 73.5 centimeters. Option B, 28 centimeters. Option C, 14 centimeters. And then option D, 10.5 centimeters. All right, guys, so let's try our hands on this question, and then we can look at the subsequent questions on this same preamble. We have two questions on this preamble, so let's go ahead and look at it. Guys, anyone working on the problem? Okay, Batra, so Batra, hi. So Batra, what do you have for us for question number 1? What is the radius of the cone? Anyone with the answer for us? Okay, so guys, let's have a look at the solution to the problem together. So let's look at the solution. Now, in our case, we've been given this diagram, the sector of a circle, and then it has been turned into a cone. So for us to be able to find the radius of the cone, we use the formula. Radius, okay, will be equal to theta, or the angle, over 360 multiplied by the initial angle, which is the capital R. Are you okay? So it is from this diagram, okay, this sector that was molded into a cone. So for us to be able to find the radius of the cone, we use the angle over 360 multiplied by the initial radius of the sector, and that will give us our answer. So our radius over here, R, will be equal to our theta that has been given to us is the angle that was given to us in the question, and that is 270. So it is 270 divided by 360 multiplied by the initial radius, which is the 14 centimeters that we have over here. So we have this multiplied by 14. Are we okay? So from here, my radius is going to be, let's do the multiplication quickly. So we have 270 divided by 360. That will give us 0.75. So we have 0.75. Then multiplied by 14. Okay, so this will now give us our answer. So multiplied by 14. So this will give us 10.5 centimeters as our answer. So yes, our answer here is option D, as shown in the expression. So guys, I hope we understood how we got it. So the sector of the circle, what was shown to us, this diagram, it was folded into a cone. So for us to find the radius of the cone, we divide the angle given in the sector over 360, then we multiply it by the initial radius of the sector. So once we do that, we get the radius of the cone. So this is the solution to the first problem. All right, so let's have a look at the second problem. Let's have a look at the second question, which is also based on this same preamble. So let's have a look at the second question. So question number 2, we have to find the surface area of the cone. So find the surface area of the cone. Are we okay? Remember, we've already calculated the radius of the cone. We said that we found the radius to be 10.5 centimeters. Are we okay? Now we've been asked to find the surface area of the cone. Okay, so we have here option A, 462 centimeters square. Option B, we have 616 centimeters squared. Option C, we have 1,232 centimeters squared. And then option D, we have 3,234 centimeters squared. Are we okay? So this is the next question that we have over here. Right. So guys, until someone engage with me, I will assume I am teaching and you guys are just observing or are learning. So I'll proceed to solve the problem without waiting for anyone to do the calculation. So if someone says hi and is engaging with me, then I'll give them some time to solve the problem. All right. So for here, to the surface area, so we are looking at the solution to the problem. Okay, so we have to calculate the surface area of the cone. So the surface area, let me make it SA. Surface area will be equal to pi small r multiplied by capital R. Okay. So from here, we have pi, which is 22/7 multiplied by 10.5 multiplied by the initial, which is 14. Okay, so from here, our pi is 22/7 multiplied by the small r that we found, or the radius of the cone is 10.5, then multiplied by the actual radius of the sector, which is 14. So we have the 14 over here. So if we do that, 22/7 multiplied by 10.5 multiplied by 14 is going to give us 462. That is what my calculator is giving me. And because it is an area, we have 462 centimeters squared as our answer over here. So therefore, option A is my correct answer in this particular case. All right, so let's have a look at another question. So let's move on to another question. So the next question we have is the volume of a cone, the volume of a cone with base radius 6 centimeters is 132 centimeters squared. Sorry, centimeters cube. You have to calculate the height. Calculate the height of the cone. You have to take pi to be 22/7. Are you okay? All right, so these are our possible options. Option A is 21 centimeters. Option B is 10.5 centimeters. Option C is 3.5 centimeters. And then option D is 1.2 centimeters. All right, guys, so this is the next question that we have. Please, let's give it a go. Right, guys, so this is the problem we have. The volume of a cone with base radius 6 centimeters is 132 centimeters cube. So we have to calculate the height of the cone. And we have to take pi to be 22/7. So this is the problem that we have. Guys, we have 2 minutes. Let's give it a try and leave our answers in the live chat for me. So anyone with an answer for me? Guys, anyone with an answer? All right, so let's proceed to look at the solution to this particular problem. As always, I'll use this color. So let's look at the solution to the problem. Now, before we look at the solution, let's read and see the parameters that we have. So they say that the volume of a cone with base radius, so it means our radius is equal to 6 centimeters. And then all right, so Angus, I hope I'm pronouncing your name right, is saying option C. So Angus is saying option C. All right, so let's see. So they are saying the volume is 132 centimeters cube. We have to calculate the height. It means we do not know the height. And then we have to take pi to be 22/7. So these are the parameters that we do actually have. So Angus is saying he has option C, which is 3.5 as his answer. Let's look at it. All right, so the volume of a cone is given to us mathematically as 1/3 pi r square h. So this is the formula for calculating the volume of a cone. Now we have to find the height, which means we need to make h the subject. So let me do the change of subject. So I'll multiply through by 3. So I'll have 3v. 3 multiplied by volume will be equal to 3 multiplied by 1/3 pi r square h. So this will cancel this. So 3v will be equal to pi r square h. To find h, I divide both sides by pi r square, pi r squared. So this will cancel this, which means my height is equal to 3 times the volume over pi r squared. So from here, I'll just do my substitution. So I have my height to be equal to 3 multiplied by the volume, which is 132, all over pi, which is 22/7, multiplied by the radius, which is 6, then squared. Are we okay? All right, so from here, all I have to do is to simply put everything I have here into my calculator. Are we okay? So what I'll do is that I have here the ratio 3 into bracket 132, bracket close. Then the denominator, I have 22/7 multiplied by 6 squared. Are we okay? So if I compute everything here into my calculator, my height will be equal to 3.5. And because all the units we've used so far is centimeters, so my unit here is centimeters. So therefore, the correct answer here is option C, as rightly said by Angus. So Angus, you are amazing, you are excellent, and you have the answer correct. Amazing, amazing. Now let's move on to the next question that we have. Let's move on to the next question that we have. So we have here the volume of a cylindrical tank is 1,100 meters cube. If the diameter of its base is 10 meters, we have to find its height. Are we okay? So we also to take pi to be 22/7. So this is our problem. So we have our possible options. Option A is 3.5 meters. Option B is 14 meters. Option C is 35 meters. And then option D, the last option, is 70 meters. Are we okay? So guys, this is the next question that we have. Please, let's give it a go. We have 2 minutes to give it a go, and after that, we look at the solution to the problem all together. Okay, so someone is saying, oh my god, maths again. Please, what do you want us to do? If not maths, what do you want us to do? If you want physics, we can do physics. If you want chemistry, we can do chemistry. It depends on what majority wants. So what do you want? Okay, you said you want some biology or physics. Okay, we can switch. We can switch in between. But let's give it a try. Physics is still going to be the same. Are you okay? Physics is still going to be the same set of calculation questions. So physics is basically still mathematics. Are we okay? But all the same, we can do that. Or like you said, we can do biology as well. So yes, I agree. We can do biology as well. So guys, we have 1 more minute. After that, then we look at the solution to this problem. So for the guys who are watching, please, there is a poll that I've just posted. Please answer honestly. Are we okay? Just answer honestly. All right. So we are almost there. The 2 minutes are almost up. Anyone with the answer for us? Okay. So guys, let's have a look at the solution to this particular problem. So let's write down our solution. Now, the first thing we want to note is that the formula for calculating the volume of a cylinder, the formula for volume is pi r squared h. Now, let's look at the parameters that we have from the question. So, we've been told that the volume of a cylindrical tank is 1100. So, our volume is 1100 meters cubed. So, we have that. And we've been given the diameter of the base to be 10 meters. Are we okay? And the question is demanding that we find the height. So the height we do not know. But we don't have the radius in this case. So the first thing we need to do is to find the radius. Now obviously the radius is equal to the diameter divided by 2. The radius is half the diameter. So our radius will be equal to 10 divided by 2. And that will give us 5 meters over here as our answer. So from here, we can just simply substitute our values into the formula for calculating the volume, and then we proceed from there. So over here, our volume is equal to pi r squared h, like I said. So our volume is 1100 is equal to pi is 22 over 7 multiplied by the radius, which is 5 squared. Then we have here h. Are we okay? So I still have here 1100, and that will be equal to 22 on 7, 22 divided by 7, 22 divided by 7 multiplied by 5 squared. That will give us 78. That will give us 78.57. So I have here 78.57 h. So I'll divide both sides by that, 75.57, 78.57. So this will cancel this. So our height is therefore 1100 divided by 78.57, and that is going to give us 14.00025, which is basically h height is equal to 14 meters. Are we okay? So from here, our correct option here is option B. Are we okay? Yes. Please, the one who was asking for us to do physics, please mention a specific topic in physics you would want us to solve so that we look at it together. All right. So let's proceed with the next question that we have. We have here a right pyramid. A right pyramid has a square base, of side 10 centimeters if the volume is 700 centimeters cube. We have to find its height. Are we okay? Yes. So this is the problem we have. So we have option A to be 7 centimeters, option B to be 21 centimeters, option C to be 42 centimeters, and then option D to be 70 centimeters. All right, guys. So this is the next question that we have over here. Let's give it a go. All right. So I'll proceed to solve the problem. So until someone engage with me, like I said, I will continue solving the problems once I write them down. So let's look at the solution to this particular problem. So we have here a right pyramid has a square base of side 10 centimeters. If the volume is 700 centimeters cube, we have to find its height. All right, so guys, I'll give you 1 minute. Let's give it a try, and then we can look at the solution together. So we have 1 minute. All right, so let's have a look at the solution to this problem. We've been told that a right pyramid has a square base of side 10 centimeters. So the length of the base is 10 centimeters. We've been told that if the volume is 700 centimeters cube, we have to find the height, and that is what we do not know. All right, so to find the volume of a pyramid, the volume of a pyramid is 1/3 multiplied by the area of base multiplied by the height. Are we okay? So this is the formula for calculating the volume of a pyramid. Now we can go ahead and do the substitution from here, or we can find the area of the base first. So the area over here, because it is a square base, the area will be length squared, which will be equal to 10 squared, and that will give us 100 centimeters squared as our answer. So now that we have the area, we can proceed to calculate the volume, which will be 1/3 multiplied by 100 multiplied by height. And the volume in this particular case is 700. So I can put my 700 over here. Are we okay? I can do that over here. So from here, I multiply through by 3. So I will have 3 multiplied by 700 is equal to 3 multiplied by 1/3 into bracket 100h. Are we okay? Because they are all multiplying each other, they will just be like that. So this will cancel this. Are we okay? So I'll have 3 multiplied by 700 is equal to 100h. If you like, you can multiply. If you like, I'm just deciding to leave it like this. So I'll divide both sides by 100, both sides by 100. This will cancel this. So my height in this case will be equal to, this will cancel this will also cancel this. So I have here 3 multiplied by 7, and that is 21, divided by 1 is still 21. So centimeters over here. So therefore my height is equal to 21 centimeters. Are we okay? So my correct answer here is option B, as shown in the possible options above. All right, so let's have a look at another question. let's have a look at another set of questions. So we have here the volume of a cone, the volume of a cone, the volume of a cone of height 10.5 centimeters is 396 centimeters cube. You have to find the radius of the cone. Find the radius of the cone. Take pi to be equal to 22/7. Alright, so guys, this is the next question we have. So I have here my possible options. Option A is 3.4. Option B is 3.5. Option C is 6. Then option D is 36. Are we okay? Alright, so guys, this is the problem we have. Let's give it a go. Anyone with an answer for us? Viewers, anyone with an answer for us? So our 1 minute is almost up. What do we have? Okay, so let's have a look at the solution to this particular problem. All right, so for this particular problem, we've been told that the volume of a cone of height 10.5 centimeters. So it means that the height of the cone has been given to us to be 10.5 centimeters. And then they're saying that the volume is 396 centimeters squared. Now we have to find the radius of the cone. So the radius we do not know, but we've been given pi to be 22/7. Are we okay? So now we have all these parameters. So from here we can proceed to find the radius. Now we know that the volume of a cone is equal to 1/3 pi r squared h. Okay, so this is the formula for calculating the volume of a cone. Are we okay? Now from here I can decide to make my h the subject first before I do the substitution, or I can just do the substitution directly. So from here I'll do the substitution directly. So my volume will be 396 is equal to 1/3 multiplied by 22/7. Then the radius is still r squared. Then the height here will be 10.5. Are we okay? So I have here 396. Then I will multiply everything I have over here. So I have 1/3. So 1/3 multiplied by 22/7. 22/7 multiplied by 10.5. Are you okay? So everything here will give me 11. So if I multiply everything here, it will give me 11. So I have here 11r squared. So I'll divide both sides by 11. So I'll have here 396 divided by 11. That will give me 36 is equal to r squared. Are we okay? So from here, to find the value of r, I bring square root to both sides, so square root of 36 will be equal to the square root of r squared. So therefore, this will nullify the roots, the square over here. So my radius will be equal to the root of 36. That should give me 6. Okay. So therefore, my radius is equal to 6 centimeters. And so therefore, my correct answer here is option C, as seen from the possible options given to me. All right. So guys, please, do we understand? Any question for me? Any questions, any comment, any suggestion? Guys, any question for me? Any comment, any suggestion? All right. So let's have a look at one last example for tonight, and then we can end today's stream early over here. Right. So here we have a water tank. A water tank is a cube. It's a cube of side 2 meters. 2 meters. The depth of the water in it is 60 centimeters. So what is the volume? What is the volume of water in the tank? In the tank. So we have here our possible option A is 2.4 meters cube. Option B is 4 meters cube. Option C is 8 meters cube. Option D is 24 meters cube. All right. Okay, so this is the question that we have. Please, we have 1 minute. Let's try our hands on the question, and then we proceed from there. This is the last question for tonight's stream, because we'll be doing IQ test later after this. So yeah, anyone with an answer for me? All right, so let's have a look at the solution to this particular problem. Now over here, they said that a water tank is a cube of side 2 meters high. So it's basically like our water tank looks something like this. Are we okay? It looks something that looks like this. Okay. Okay, so this is what our water tank probably looks like. And then we've been told that it has side of 2 meters. So because it's a cube, all the sides are the same. Okay, so it has 2 meters. And the depth of the water in it is 60 centimeters. What is the volume of the water in the tank? Okay, so the depth, let's assume that this is the water, this is the depth of the water inside. So the water is somewhere here. Okay, so making it like this. So all right, so this is the water inside the tank. Okay, and this depth is what they are calling 60 centimeters. Okay, so now what is the actual height of this particular water tank. Are we okay? Now, to find the volume of the tank, the volume has to be area, the area of the water tank, area of tank, okay, multiplied by the height. Are we okay? The area multiplied by the height. Now, from here, now we have to calculate the volume of water in it. So the volume of water. So this is the height of the water. We have to calculate the volume of water. So the volume of water will be the area of the tank multiplied by the height. Now the height over here is the 60 centimeters. The height is the 60 centimeters given to us. So when we convert that to meters, that will be 0.6 meters. Let's take note of that. Now the area of the tank, as we know, the area of a cube will be length squared. So here will be L squared multiplied by H. The length over here is 2. So we'll have here 2 squared multiplied by the height, which is already 0.6, as we have seen over here. So here we have 2 squared, which is 4, multiplied by 0.6. Are we okay? And that will give us the volume. So the volume in this case will be 4 multiplied by 0.6. Are we okay? And 4 multiplied by 0.6, that is going to give us 2.4 meters cube as our answer over here. So for this particular problem, our answer is option A, which is 2.4 meters cube. Are we okay? Yeah, so guys, this is how we solve some problems on mensuration. Like I said, these are problems relating to how to calculate the volume, the area, and then the corresponding parameters that has to do with the volume of a cube, of a tank, of a pyramid, of a cone. These are some problems on it. Like I said, these are past questions that has been solved for WAEC candidates, and these are some questions that I have for you guys tonight. Now, because the engagement is low, I will end today's stream over here, and then exactly at 8 p.m. GMT will continue with the IQ test. So for those of you who are watching and you are interested in the IQ test, rather, I'll see you in a couple of minutes where we'll be streaming on some IQ test questions. So the questions will be random, and you guys will have to think critically to be able to find the answer to that. All right. So in the absence of any other comment, any other contribution, any other point of view, I would like to move the stream to an end earlier today than expected. But like I said, I will see you in the IQ test, which is bound to come in the next 15 to 20 minute time. All right, guys. So thank you so much for joining the stream. I'm excited that you guys always make time to join the stream. I really appreciate you guys. Thank you once again, and I'll see you guys in the next stream. Are we okay? Bye-bye.
Oh, hey, hey, it's time to learn. Grab your books, it's your turn. Numbers, dance, and questions, power, get ready. It's Sharky Hour.
In the world of learning, bright and new, we solve with joy, me and you. Maths and science, we dive so deep. Dreams to chase and goals to keep.
No fear.